All right, welcome back. So today we're going to be solving Leetcode number 49, group anagrams. Given an array of strings, group the anagrams together. Right? The result can be returned in any order. So what an anagram is in this case, an anagram is, two words are anagrams if the number of occurrences of the letters in each of the words are the same. So EAT and TEA have the same number of occurrences of each letter in the word, right? One E, one A, and one T. So those words would be considered anagrams. So we're going to break this down with a little excali draw as usual. All right, so what we're going to do here is basically kind of work with this representation from the sample that we just went over. The way that we're going to solve this problem is we're going to use a hash table or a dictionary. The words are interchangeable. Hash tables are basically a way of representing data with keys and values, right? Where values are associated to a specific key. The keys are in a set, right? So you can't have the same key in a hash table. The keys have to be unique. And the values can hold basically anything, but the keys have to be hashable, right? And that's an important thing that we're going to talk about here in a second. So in this case, right, we basically use a hash table where the keys are going to be the representation of the anagram, right? So a way to kind of classify these anagrams. And what basically we want to do is use the keys to represent the occurrences of each of the letters in the string, right? So we want to basically be able to associate all the anagrams with one E, one A, and one T together, all the ones with one B, one A, and one T together, etc. Right, so the question that we just went over, how do we represent the occurrences of letters? Right, the value needs to be hashable. In this case, we're using Python, so the value needs to be hashable, right? Meaning that they are immutable, right? The value cannot be changed once it is assigned. You can use this little example here, right? That pull from ChatGPT, where if you assign a variable to equal a string, right? In this case, s equaling hello, you cannot then go and change the value of a specific character in that string by using, array indexing, because it will raise an error, right? Strings are immutable, right? They're hashable, so they are immutable, and so that is what we kind of have to work around. So that gives us two options. It gives us two options for this representation problem. The first thing we can do is to represent the anagram as a string, right? And so what we need to do is, in order to accomplish this, iterate over all the words and then sort the word. Right, so sorting the words in this case would sort the string in alphabetical order, right? So instead of EAT, right, once it's sorted, it would become AET. And the same thing for T, right? Running the same algorithm across words with the same occurrences of characters, they're both going to come out with the same result. And that actually gives us a standard that we can use for the representation in our hash table. Right, as you can see right here, we would use that AET, that sorted version of the word, as the representation. And then all the words that, once they are sorted, equal that same representation, we know that they are anagrams, so we would group them together in the value of that key. Right, so the time complexity of the problem is going to be m times n log n. M here represents the number of strings in the input array, and the n log n represents the time it takes to sort each individual word. The space complexity would be m times n, because we would be storing m strings with at least n characters. So we're going to put the solution up first, and then we're going to go over and talk about the second solution, because the second solution is just a tiny bit better, but it involves an important thing to know when you're doing coding interviews. So first, we'll solve this with the string method. Okay, so here we are in Leetcode. What we're going to do is we're going to code up the string solution. So the first thing to do is we want to start off with our dictionary SO. Then we want to loop over all the words in the input array. And then we want to get the sorted version of the word, right? So the sorted word should equal an empty string that joins the sorted word. Right, now it's important you do this join here, because sorted actually is just going to return an array. So what we're going to do is basically take all the letters in that array and join them together into a string and use that as the hashable key, right, for our SO dictionary. So then once we have that sorted word, I'm going to see one, okay, do we already have other words that match this sorted version of the word that we're going over right now? So I'm going to do if sorted word is in SO, then we need to do SO at sorted word dot append the unsorted version of the word. Otherwise, this is the first time we're seeing this, so we want to set the sorted word sorted word to equal an array with the unsorted word as the only entry. That's pretty much all we need to do. So after this, we can return result, or return rather a list of the values in our dictionary, right? So the values of our dictionary at this point are going to be all the arrays grouped together by anagrams. I just want to return the list of those to combine them all into one array. So we're going to run this. You can see that we got all our test cases accepted, so we can submit. And we come in with a pretty good time score on this, beating by 82%. So now we're going to head over and try the other solution. So the other way to represent these strings for our hash table so that we know if we're dealing with an anagram or not is to use a tuple representing ASCII values, right? So a little bit of setup here. All the possible characters that you can type into a computer have a representation or kind of a number to represent them in binary. When this binary version is converted into base 10, all the alphabet characters fall into the range between 97 and 122. Right? If you don't know what base 10 or ASCII or kind of these encoding standards are, maybe want to go check out a short video on that. It's a pretty simple concept, but basically it gets to the point where all of there's kind of 26 different numbers that represent each individual character. So basically we can use that to create an array of length 26 with all the values initialized at 0, and then increment that value at the position of the ASCII value for each occurrence of the string. So in this case, the ASCII value of A is 97, the value of B is 98, and so on until we get to Z. Basically what this allows us to do, like I said, is we create this 26 entry array where each index represents that position of the letter in the alphabet in ASCII. And then as we iterate over words like EAT, we just increment every time we see the value of an individual character. So we say, okay, this has one E, so we increment that. It has one A, we increment that right here, and then it has one T, so we increment that as well. And then we would actually have to turn this array into a tuple, right? Because arrays are mutable, tuples are not. The values for our keys have to be hashable, so we would convert this array into a tuple. And it would use that as the keys for a hash table. And the values stay the same, right? Just the anagrams grouped together in an array. Now, the important thing to say with this, right, is the time that you save by not needing to sort the array. Right? So our time complexity goes down now to m times n, where for each string in the input, we need to iterate over it, right? So at least n times, right? And so we're not sorting at those because we can actually just get that anagram representation, right, by just iterating over one time as opposed to sorting, which takes n log n. Just that one iteration and creating that ASCII representation takes n time, right? Our space complexity stays the same. So now we're going to go over and code up that ASCII solution. All right, so we're back in Leetcode doing our anagram solution using ASCII representation. So same thing as before, we're going to iterate over all the words in the input array. And then from there, we are going to create a representation of the word in binary. So what we're going to do is create a little ASCII array, and we take the number 0 and make a 26 entry array. Iterate over all the characters in the word, get the position of the word in ASCII by using this built-in order function, right? So this is going to return the number, the base 10 representation of the ASCII value for this character, right? So basically, we want to get the order of character, and then we want to subtract the order of A. So basically, what this does is it kind of it's like a modulo kind of operator. We're basically kind of restricting, right? Kind of taking that starting value and basically turning all these ASCII values, which are normally between 97 and 122, to be from 0 through 26, right? To make it easier, so we can use that when it comes to indexing for our ASCII array. So we're going to take this position number, right? This number from 0 to 26, and then we're going to increment that in our ASCII array. So ASCII at position plus equal 1. Now, once we have that, we basically just need to turn this into a tuple. And then use that when we're looking for other anagrams. So if you've seen that ASCII representation before, we just want to append the word onto it. And if not, then we want to do the same thing we did before, which is add a one entry array with the unordered version of the word. Return the same thing as we did before, return the list of soda values. And then as we look over this should be pretty good. So we are going to run this. All right, got accepted, hit submit. And we can see that we solved it again. Probably a little bit slower because of the way that I'm initializing these values, but as you can see, it works, right? And our time complexity is going to be better than the one before. So yeah, that's all we have for this problem. Thank you all for watching and have a good rest of your day.